Hello students, welcome to Physics CT Sankalp classes. In the last class, we started the discussion on dual nature of matter and radiation. We discussed some we discussed the synopsis and some numericals related to that. So today we are going to see the continuation of that. So we'll start our discussion from 26th problem. The problem follows like this. Calculate the de Broglie wavelength of an alpha particle of mass 6.576 into 10 to the power minus 27 kg and charge 3.2 into 10 to the power minus 19 coulomb, accelerated through 2000 volt. Okay, accelerated to 2000 volt. So you have the formula. You have the formula lambda is equal to h divided by mv. You know that kinetic energy is equal to half mv square, but kinetic energy I can write it as E into V. Electron volt is equal to mv square. So I want mv. mv is equal to 2qv into m. Why? Because so it is nothing but root of root of 2qvm. V is nothing but voltage, m is the mass. Just you are going to multiply and divide by m. Okay, now lambda is equal to h divided by root of 2qvm. So the values is 6.6 into 10 to the power 34 minus 34, right? The h value whole divided by square root of 2 into what is the charge of alpha particle. They given 3.2 into 10 to the power minus 19. V is 2 into 10 to the power 3. ಯಾಕಂದ್ರೆ 2000 ಕೊಟ್ಟಿದ್ದಾರೆ. ಅನ್ನ 2 into 10 to the power 3 ಅಂತ ಬರಿತಾ ಇದ್ದೀನಿ. Into they have given the mass 6.576 into 10 to the power minus 27. ದಷ್ಟನ್ನು ರೂಟಲ್ಲಿ ಬರುತ್ತೆ. ಈಗ ಫರ್ದರ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ. ಟ್ರೈ ಮಾಡಿ ಅದನ್ನು ಸಾಲ್ವ್ ಮಾಡಿ. if you simplify this further, 2.28 2.75 ಬರುತ್ತೆ into 10 to the power minus 13 meter ಬರುತ್ತೆ. Option 4. Next, if the stationary proton and alpha particle are accelerated through same potential difference, the ratio of de Broglie wavelength will be the ratio of de Broglie wavelength will be so okay, as you know that the gain in the potential kinetic energy of the charged particle after moving through a potential difference of V is given by electron volt, that is also equal to half mv square, correct? So where V is the velocity of the charged particle, so accordingly in the previous thing what we have written, mv is equal to root of 2mqv. So de Broglie wavelength, so lambda is equal to h divided by root of 2mqv. Now we can say it is inversely proportional to mass q everything, right? So lp is divided by l alpha is equal to square root of, so mass of alpha, charge and volt divided by mass of proton, charge and volt. Okay, so as they've told that the same potential, so this and this get cancelled. Okay, this get cancelled out of both the mass, it is 4 times. Okay, 4 times the mass of proton, charge is 2 times the charge of proton, whole divided by mp qp. mp and qp get cancelled, so it comes root, so it is root of 8 is nothing but 2 root 2. So the ratio will be 2 root 2. Option 3. Okay, ಅದು ಬರ್ಕೊಂಡ್ರೆ ಅನ್ಸುತ್ತಲ್ಲ. The next problem, The threshold wavelength of tungsten is 20, that is 2300 Armstrong. If UV light of wavelength 1800 Armstrong is incident on it, then the maximum kinetic energy of the photoelectrons would be about, okay, would be about. So you know the equation, that is kinetic energy is equal to H mu minus H mu naught. So I can write this as C by lambda, right? So Hc by lambda minus Hc by lambda naught. So Hc is common, 1 by lambda minus 1 by lambda naught. So lambda, lambda they given as 1800 Armstrong ಅಂದ್ರೆ 10 to the power 2 into 10 to the power minus 10. So this is the 10, 18 into 10 to the power minus 8. ಅದೇ ಥರ lambda naught is equal to 23 into 10 to the power minus 8. Okay, so h into c can be written as h value ಗೊತ್ತು, c value ಗೊತ್ತು, ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡಿ, ಓಕೆ, ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಲ್ಲಿ ಇಟ್ಕೊಂತೀಯ. ಸೊ ಟ್ರೈ ಮಾಡಿ. h value is 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8. So when you solve that, that is hc is equal to ಮಾಡಿದ್ರೆ, and you have to divide it by 1.6 into 10 to the power minus 19. You will get 1.23 into 10 to the power minus 6 ಬರುತ್ತೆ. ಅದನ್ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. 1.23 into 10 to the power minus 6, 1 divided by 18 ತಾನೆ, 18 into 10 to the power minus 8 minus 1 divided by 23 into 10 to the power minus 8. Okay. ಸೊ ಈಗ ಇಲ್ಲೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, 1.23 into 10 to the power minus 6 into 10 to the power 8 ಕಾಮನ್ ತೆಗಿತಾ ಇದ್ದೀನಿ. ಕೆಳಗೆ 18 into 23, so 23 minus 18. So 1.23 into 10 to the power 2. So this is 5 divided by 18 into 23. So 18 into 23 is 414 and so ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ you can write this 1.23 ಅಂತ ಏನಿದೆ ಅದನ್ನ ನಾನೇನು ಬರಿಬೋದು 123 divided by 100 into 10 to the power 2 ನ 100 ಅಂತ ಬರಿತೀನಿ, ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ 5 divided by 414. ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡಿ 123 into 5 divided by 414 ಸಾಲ್ವ್ ಮಾಡಿ. So you'll be getting 1.485, and approximately it is 1.49 electron volt. So option 1 is the right answer. ನೀಟಾಗಿ ಬರ್ಕೊಳ್ಳಿ, ಸೊ ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಸ್ವಲ್ಪ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡಬೇಕು ಇದನ್ನ. Okay, so next problem. An ultraviolet light bulb emitting 400 nanometer and an infrared light bulb emitting at 700 nanometer each are rated at 130 watt. Then the ratio of number of photons emitted per second by the UV and IR sources. Okay, so you have the equation. Okay, you are going to use the equation directly. That is N is equal to I divided by H nu. So this is the relation. So that's nothing but I is equal to NH mu. So number of ಅಂತ ಹೇಳ್ತೀವಿ, ಕರೆಕ್ಟಾ? So finally I can write this as I lambda divided by HC ತಗೊಂತೀನಿ, HC. So you can say N is directly proportional, right? N is directly proportional to lambda from this equation. So N UV divided by NIR is equal to, so lambda UV divided by lambda IR. So lambda U is nothing but so 400 divided by 700 nanometer cancel ಆಗೋಗ್ಬಿಡುತ್ತೆ. So it is 4 divided by 7 is 0.57. So option A, that's option 1. Next, I hope you're clear. Next, in a cooler tube, the minimum wavelength of X-rays coming out is 2 angstrom. Then the operating voltage of the tube is, so you have the formula lambda is equal to 12400 divided by 2. ಯಾಕಂದ್ರೆ ಅಲ್ಲೇನು voltage just a minute. Okay, the formula is V. So V is equal to 1240 divided by lambda. So 12400 divided by 2. 62. So it is 6200 ವೋಲ್ಟ್ ಆಗುತ್ತೆ, ಬಟ್ ಅದಿಲ್ಲ. ಸೊ 123, ಸೊ 6.2. So V is equal to 6.2 kilo volt. Next, an ultraviolet photon and an electron has same de Broglie wavelengths, then the energy of the photon. So you have the equation. So E1 is equal to Hc by lambda. Okay. So E2 is equal to P square divided by 2m. One is for electron, the motive force. So non-realistic electron is like this. So you can write it as h square divided by lambda square 2m. So finally h square c square divided by lambda square 2 times t m into c square multiplying. I'm going to multiply and divide by c square ಮಾಡ್ತೀನಿ ಇಲ್ಲಿ. ಅವಾಗ E2 by E1 is equal to E2 by E1 is equal to Hc by lambda. ಸೊ ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಯು ನೋ ದಟ್ ಹೇಗೆ ಅಂದರೆ ಇ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಸ್ಕ್ವಯರ್ ಡಿವೈಡೆಡ್ ಬೈ 2m ಅಲ್ವಾ. ಸೊ ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನು h ಬೈ ಎಮ್ ವಿ. ಸೊ ಪಿ ಅಂದ್ರೆ ಏನು, ಸೊ ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು h ಬೈ ಪಿ ಅಂತ ಬರೆದ್ರೆ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು h ಬೈ ಲ್ಯಾಂಬ್ಡಾ. ಅದನ್ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿರೋದು h ಸ್ಕ್ವಯರ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಸ್ಕ್ವಯರ್ ಇಂಟು 2m ಅಂತ ಬರಿತೀವಿ. ಈ ಟರ್ಮ್ಗೆ ಸಿ ಸ್ಕ್ವೇರ್ ಮತ್ತು ಸಿ ಸ್ಕ್ವೇರ್ ಮಲ್ಟಿಪ್ಲೈ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಆ ರೇಷಿಯೋ ಬರುತ್ತೆ. ಓಕೆ, E2 is h ಸ್ಕ್ವೇರ್ ಸಿ ಸ್ಕ್ವೇರ್ 2m ಸಿ ಸ್ಕ್ವೇರ್ ಇಂಟು ಲ್ಯಾಂಬ್ಡಾ ಡಿವೈಡೆಡ್ ಬೈ ಹೆಚ್ ಸಿ ಆಗುತ್ತೆ. ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಸ್ಕ್ವಯರು ಸ್ಕ್ವೇರು ಸಿ ಕ್ಯಾನ್ಸಲ್, ಸ್ಕ್ವೇರು ಲ್ಯಾಂಬ್ಡಾ ಕ್ಯಾನ್ಸಲ್. ಸೊ ಅವಾಗ ಹೆಚ್ ಸಿ ಡಿವೈಡೆಡ್ ಬೈ 2mc ಸ್ಕ್ವೇರ್. ಹೌದಾ? E2 by E1 lambda into. So so if you observe that hc by lambda is equal to E1, right? So compare ಮಾಡಿದಾಗ, so great the energy of photon, right? So energy of photon is greater than the kinetic energy of electron. Energy of photon is greater than the energy of kinetic energy of electron ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂದರೆ ಡಬಲ್ ಆಗುತ್ತೆ, ಇ ಸ್ಕ್ವಯರ್ ಆಗುತ್ತಲ್ಲ ಅಷ್ಟೇ. ಯಾಕಂದರೆ ಎಚ್ ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ E1 ಆಗುತ್ತೆ, ಸೊ ಗ್ರೇಟರ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ನೋಡಿ, the light of wavelength 3500 Armstrong is incident on two metals A and B whose work function are 3.2 electron volt and 1.9 electron volt respectively. Which metal will emit photoelectrons? Okay, see, you have the formula. Okay, the work function is given as 5, right? So 5 naught is equal to hc divided by lambda naught. Okay, if it is in electron volt alittu andre, if it is in electron volt alittu andre, you can write it as 5 naught is equal to hc divided by E into lambda naught. ಸೊ ಈಗ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಎಚ್ ಸಿ ಡಿವೈಡೆಡ್ ಬೈ ಇ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಇಟ್ ಆಸ್ 1 2 3. ಕರೆಕ್ಟ್, ನಾವು ಆಲ್ರೆಡಿ ಮಾಡಿಸಿದ್ದೆ ನಾನು. 1 2 3 7 ಅನ್ಕೋ, ಡಿವೈಡೆಡ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ 5 ನಾಟ್. ಸೊ ಈಗ ಏನು ಕಂಡುಹಿಡಿತೀನಿ, ಸೊ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 2 3 7 ಡಿವೈಡೆಡ್ ಬೈ 5 ನಾಟ್. ಓಕೆ, ಅದು ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಆಯಿತು. ಯಾವುದಕ್ಕೆ? ಇದು ಜನರಲ್ ಫಾರ್ಮುಲಾ. ಈಗ ಇದು ಜನರಲ್ ಫಾರ್ಮುಲಾ. ಈಗ ಏನು ಕಂಡುಹಿಡಿತೀರಾ, ಫಾರ್ ಮೆಟಲ್ ಎ ಆ್ಯಂಡ್ ಫಾರ್ ಮೆಟಲ್ ಬಿ ಸಾಲ್ವ್ ಮಾಡಿ. ಸೊ ಈಗ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಅದೇನು 1237 ಡಿವೈಡೆಡ್ ಬೈ 3.2 ಮಾಡಿ, ನೆಕ್ಸ್ಟ್ 1237 ಡಿವೈಡೆಡ್ ಬೈ 1.9 ಸಾಲ್ವ್ ಮಾಡಿ. ಈಗ ಫಾರ್ ಮೆಟಲ್ಗೆ, ಮೆಟಲ್ ಹೇಗೆ ಎಷ್ಟು ಬರುತ್ತೆ? ಸೊ ಇಟ್ ಈಸ್ ಅರೌಂಡ್ 3867 ಆಮ್ಸ್ಟ್ರಾಂಗ್ ಬರುತ್ತೆ. ಸೊ ಫಾರ್ ಮೆಟಲ್ ಬಿ 6513 ಆಮ್ಸ್ಟ್ರಾಂಗ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆಗಿ ಬರುತ್ತೆ. ಸೊ ಅವಾಗ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಯಾವುದು? ಸೊ ಇನ್ಸಿಡೆಂಟ್ ವೇವ್ಲೆಂತ್ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ ದ ಥ್ರೆಶೋಲ್ಡ್ ವೇವ್ಲೆಂತ್. ಹೌದಾ? ಸೊ ಇನ್ಸಿಡೆಂಟ್ ವೇವ್ಲೆಂತ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು? ದೇ ಗಿವನ್ lambda is equal to 3500 ಆಮ್ಸ್ಟ್ರಾಂಗ್. ಬಟ್ ಎರಡು ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಈ ವೇವ್ ಲೆಂತ್ಗಿಂತ ಇದು ಜಾಸ್ತಿ ಇದೆ. ಸೊ ಬೋತ್ ಎ ಅಂಡ್ ಬಿ ಬಂದು ಏನಾಗುತ್ತೆ? ವಿಲ್ ಎಮಿಟ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ದೇ ಬೋತ್ ವಿಲ್ ಎಮಿಟ್ ದ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಚೆಕ್ ಮಾಡಿ ಒಂದ್ಸಲ. ಓಕೆ, ಅರ್ಥ ಆಯ್ತಲ್ಲ ಎಲ್ಲರಿಗೂ? So next problem, the de Broglie wavelength of an electron, the de Broglie wavelength of the electron in the second Bohr orbit, in the second Bohr orbit, in the second Bohr orbit is anta kelidare. So you know the formula that so the de Broglie wavelength is given as 2 pi r is equal to n into lambda. So they given ಅಂದ್ರೆ ಇದು ಆರ್ ಎನ್ ಅಂತ ತಗೊಂತೀವಿ. ಸೊ ಎನ್ they given as 2. n they given as 2, right? So again it is 2 pi r2 is equal to 2 lambda. 2 pi 2 and 2 get cancelled. So pi r2 is equal to lambda. So you know that Rn is equal to n square r1. So it is r2 is equal to 2 square into 0.53. So you will be getting 4 into, so it is 2.12 ಬರುತ್ತೆ. So the lambda is equal to 3.14 into 2.12. 6.66 Armstrong ಬರುತ್ತೆ. So option 2. ಬರ್ಕೊಳ್ತೀನಿ. Okay. Yes. So next problem observe ಮಾಡಿ. The surface of a metal is illuminated with the light of wavelength 400 nanometer. The light of wavelength 400 nanometer. The kinetic energy of the ejected photoelectrons was found to be 1.68 electron volt. The work function of the metal is, okay, so we know that hc by lambda is equal to so it is hc by lambda minus work function is equal to kinetic energy, and the kinetic energy is equal to this formula. So from this I can write W is equal to hc by lambda minus kinetic energy. So ಈಗ ಅವ್ರು ಆಲ್ರೆಡಿ ಎಚ್ ಸಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? ಸೊ 1240 divided by 400, okay, minus 1.68. So you solve this, you will get the work function. Try ಮಾಡಿ ಅದನ್ನ. So when you solve this, you will get it 1.42 electron volt. So it is option 1. ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಸೊ ದ ಬೇಸಿಕ್ ಫಾರ್ಮುಲಾ ರಿಲೇಟ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. Okay. After absorbing a slowly moving neutron of mass m1, a nucleus of mass m breaks into two nuclei of masses m1 and 5m1 respectively. If the de Broglie wavelength of the nucleus with mass m1 is lambda and de Broglie wavelength of nucleus will be, so in terms of moment of inertial ಮಾತಾಡ್ತೀವಿ. Okay, so momentum of inertia ಅಂತೀನಿ. So in terms of momentum, linear momentum, okay, the things you can write it as, that is the initial momentum is equal to 0. So you can say the final momentum is equal to P1 plus P2 na. Okay, as you know that according to the thing, uh, initial momentum is equal to final momentum, the thing whatever they're given. So accordingly this becomes 0. So 0 is equal to P1 plus P2. So again ಹೇಳ್ಬೋದು P1 is equal to minus P2 minus P2. ಈಗ this is the thing you remember. Now you have the formula lambda is equal to h divided by p, right? So ಈಗ lambda 1 is equal to p1 ಆಗುತ್ತೆ. So lambda 2 is equal to h divided by p2. Okay, so ಈಗ ಏನು ಹೇಳ್ತಾ ಇದ್ದೀವಿ, accordingly magnitude of lambda 1 is equal to magnitude of lambda 2 ಅಂತ ಕರಿತೀವಿ. So finally I can say lambda 1 is equal to lambda 2 is equal to lambda ಅಂತ ಬರಿಬೋದಾ? ಆಪ್ಷನ್ ಸಿ. ಅರ್ಥ ಆಯ್ತಾ? So I hope you are clear with this. So this completes the chapter dual nature of matter. So next class we'll start with the new topic. So thank you all. Have a great day.